So welcome to our review for the final exam. I'm going to be going through 30 different problems and how to work them. For every single problem, you should be working this out. You should input your work into Pear Deck, and you should not be fast forwarding just to get answers. You've got to know how to work these out. So let's go ahead and get started. The total cost in dollars to buy uniforms for the players on a volleyball team can be found using the function C equals 34.95U plus 6.25. That seems like it'd be a little bit important, so I'll go ahead and underline it. Where U is the number of uniforms bought. Probably also important. If there are at least 8 players, but not more than 12 players on the volleyball team, find the domain in the range. All right, so let's go ahead and start analyzing that. First thing, let's talk about this formula. So C, and I'll go ahead and write this out as a function. So my C value is going to be my cost, and my U value is uniforms. So that means that my uniforms are my domain, and my cost is my range. So let's first deal with domain. All right. So first thing, they said at least 8 players. So if I was to write out all of the numbers that are in between there, and I'm only doing this for illustration purposes, I would say at least 8 players. So I can have 8, I can have 9, I can have 10, but I cannot have 7. So 7 would not make it on my domain, but not more than 12. So I can have 11, I can have 12, but I cannot have 13. So my domain is equal to 8, 9, 10, 11, 12. I'll write that out so that way I'll remember that. All right. In order to calculate my range, I've got to plug in each one of these values. So I would change my U into whatever the value of U is. So 34.95 times 8 plus 6.25. And I would do the same thing over and over in order to find my range. All I'm doing is just plugging in my U values, my domain, in order to get the associated range. All right. So, of course, this is probably going to take a while, but I can also use my calculator to do this. So, what I'm going to go ahead and do is I'm going to swing over to my calculator and I'm going to graph this. I'm going to go ahead and graph this, okay? Now, whenever I graph things, I absolutely have got to utilize my my function name, but I'm going to call my variable, my independent variable, my domain, x, okay? So I'm going to call this C5 because this is question 5 of x. The equation is 34.95x plus 6.25. So I got some kind of line. Now I'm going to go ahead and I'm going to look at my table. Control T. All right. For each one of these, I'm going to look for their associated value over here. If I don't see the number, I can also go to my main screen and call it up. So I can go ahead and scroll down. I can look for 8, 9, 10, 11, 12. And these would be all of my range values here. Or let's say that they were all spaced out or they were a decimal. I can go to a calculator screen and I can call them up. So equation C5 of 8, equation C5 of 9, equation C5 of 10, equation C5 of 11, equation C5 of 12. So I can type that in. I'm inputting my domain here, and I'm asking it to spit out my range. So let me write those down. 285.85, 320.80, 355.75, 390.70, 425.65. All right. So as you can see over here, these guys are my range. So my range is going to be 285.85, 320.80, 355.75, 390.70, and of course 425.65. So as a review, domain, my input, independent variable, my x's, in this case uniforms, and my range is my output, my y values, and in this case my c, okay, my dependent variable. Now, for every single one of these, this is how you're going to do it. If it is a discrete function, meaning certain numbers that we can count, number of shirts, number of people, number of items, we can't cut them in half. They can't have decimals. So they absolutely have got to be discrete, which means we have to take their numbers and plug them in individually. Okay? All right. Let's take a look at the very next one. So here they're asking me to find my domain and my range. I see that my graph is connected the whole way through. That means that this guy is going to be continuous. So I'm going to go ahead and get started by first writing out my basic part of my continuous domain and range. Let's go ahead and first take a look at my domain, which is my x's, and we'll follow that up by looking at my range. So now I'm going to look at my graph and I'm going to say, all right, I'm looking at this and I need the very smallest x. So I look at my x-axis. I'm going to come in from this side and I'm going to say, all right, let me actually go ahead and I will draw an imaginary pencil here. So I'm going to take my imaginary pencil and I'm going to run it all the way, just like I read from the left to the right. And the very first point that I encounter is located at x equals 0. So I'd write in that number. I see that this particular point has a filled in dot, extra line. Now I'm going to do the same exact thing from the other side. So now I'm going to go ahead and start way out here, and I'm going to try and find the largest x value I can find. And that's the very first point that I touch. It's located at x equals 28. I see that the dot associated with it is filled in, so I would put my extra line. Now I'm going to deal with my range. So let's go ahead and clear off my graph a little bit. In order to do my range, I'm going to start way down here at the bottom, and I'm going to head up. So we're always going from smallest to biggest. So I'm going to go ahead and grab my imaginary pencil, and I'm going to move it up until I find the very first point on the y-axis. And it looks like over here on the pink axis, my y, it touches at 0. So I'm going to write in that number. Again, this dot is filled in, so I'll put my extra line. Now I'm going to go ahead and I'm going to go way up to the top and I'm going to look for the very highest point. I'm going down, 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 down. And I see that it's right here. This point is at y equals 9 and that dot is filled in, so I get an extra line. There's my domain. There is my range. All right, same exact thing again. So we're dealing with domain, range. All right, so let me go ahead and draw in my little pencil. We're going to start with our domain. So of course, because this guy is continuous, I'm going to go ahead and get that set up like that. And now I'm going to go ahead and I'm going to first look for my x value that is the furthest to the left. So I'm going to go in. And that is the very first point that I come across, located here at x is equal to -2. I see that the dot located there is filled in, so I would put my extra line. Now I'm going to go ahead and grab my pencil, and I'm going to come all the way over here, and I'm looking for the very largest x value. And I found it, the very first point that I encounter coming in from that direction. It is located at x equals 4. However, this dot is not filled in, so I will not put an extra line. Now I want to go ahead and I want to deal with my range. So I'm going to start at the very bottom, and I'm going to move my little imaginary pencil up. And the very first point I encounter is at y equals -3. I see that particular point is filled in. So I'm going to put my extra line. Now I'm going to go ahead and I'm going to come down from the very top to see the highest point that I encounter. It's located at y equals 3. However, this dot is not filled in, so I will not put my extra line. Now I have my domain as well as my range. All right. So here they're asking me to write the equation. This is going to be a line. All right. So first thing I want to do is I want to calculate my slope. My slope is always going to be equal to this formula. y2 minus y1 over x2 minus x1. So let me go ahead and take a look at all of my options. So I'm looking for the points that would be the easiest to deal with. I'll go ahead and get this set up by writing in my negatives. I want to make sure that I always write in those negatives first, because if I don't, it could change the value of my slope. So now I'm going to look at my values. I'm looking for the smallest numbers possible, and I'm going to try to avoid negatives. And I prefer whole numbers because they're a little bit easier to deal with. Pretty much everybody has a decimal and everybody has a negative. So I'm just going to pick the ones that are the closest to 0. So I'll pick this guy. And I'll pick another one that'll be kind of easy. I'll pick this guy. All right. So now I'm going to go ahead and pick my biggest x to be x2. Now I'm going to put its same y as y2. And of course, my other x as x1. And its associated y as y1. Let's go ahead and write those in. 0 minus 12, negative 3.5 minus negative 7.5. I see a double negative. I'm going to change that to a positive. Now I can continue forth with simplifying. Negative 12, all divided by positive 4. And I find out that my slope is equal to -3. Utilizing that slope, I can then plug it back in to y equals mx plus b and solve for b in order to get my full equation in the form of y equals mx plus b. So, first thing, I'm going to pick a point. I'm going to pick this guy because it has a 0 in it, meaning less work on my part. So I'll say y equals mx plus b, and I'm going to plug in those values. So here's my x, here's my y, And of course, here's my m. Let's get those guys plugged in. 0 equals negative 3 times negative 3.5 plus b. All right. So now I'm going to go ahead and perform the operations. I'm going to pull up my calculator here. I just needed a little help just to make sure that I'm going to multiply this correctly. And I get positive 10.5 plus b. So now I'm going to move that 10.5. And I end up with the value of b equals negative 10.5. Whenever I pair that information that I just got with my slope, I then have my complete equation. I could have also verified my b value by using nsolve. So I could actually type it, or I can hit menu 3-1. But I'm going to go ahead and use this. So 0 equals negative 3 times negative 3.5 plus b comma b. And it should spit out the exact same answer. And it does. Negative 10.5. Exactly what I got before. Now, I know that I have my equation correct. However, I want to run a linear regression in order to verify that I did all of this right, because it will tell me this entire equation. So I'm going to go ahead and I'm going to go to my home screen and start a new spreadsheet. Now, this is question number 4. So I'm going to call these my x's from question 4, my y's from question 4. Here I'm going to go ahead and put negative 7.5, negative 3.5, negative 1, positive 2, 3.5. And I'm going to type in their associated y values. 12, 0, negative 7.5, negative 16.5, negative 21. All right. So now I have all of that information. I'm going to go ahead and run my regression. Menu, statistics, stat calculations, linear regression, y equals mx plus b. As I've mentioned multiple times in class, I always name these with the same convention because sometimes these lists are going to get crazy. So my x's, my y's, and I'll rename my function as f4, just in case I want to graph it or look at it later. I'm going to click OK, and notice it gave me the exact same answer. Y equals negative 3, x minus 10.5. All right, let's go ahead and take a look at the next one. Number 12. What is the equation of the line that has a slope of 0 and passes through that point? Okay, so before we get into this, I do want to make sure that you guys remember something. So, we had 4 different kinds of slope. We had positive, negative, 0 slope, a flat line, and a straight up and down one that was called undefined. These two guys over here always have an equation of y equals mx plus b. Always. Anything with a slope of 0 should have an equation of y equals a number. Anything that's undefined should have an equation of x equals a number. Now, based on the fact that they told me that this slope is 0, I should automatically know y equals whatever that number is. But let's imagine that you forgot that, okay? So what I'm going to do is I'm going to solve this just like I would solve a normal y equals mx plus b. So first thing I'm going to do is I'm going to say y equals mx plus b. Let's plug in that slope. And of course, my x x value and my y value. So let's write those in. So negative 8 equals 0 multiplied by positive 6 plus b. So I'll go ahead and continue simplifying this, and I find out that my b value is negative 8. I'm going to take that along with my slope, and I'm going to plug those guys back into an equation. So now I have my equation. However, what we've also known in algebra is that if something's multiplied by 0, it's still 0. I don't have to write it in. So my equation is y equals negative 8. Same exact thing that I would have known had I just remembered that my slope is equal to 0. All right, let's take a look at the next one. So here they want us to find the equation in standard form of a line that passes through this point and has a slope of that. Okay, so let us go ahead and get that plugged in. First step, y equals mx plus b. So I'm going to plug in my x value, my y value, and of course, my slope. So let's get those plugged in. All right. So I could go ahead and use an n solve right here, and I could solve for b. I can also solve it by hand. So I'll do both. So I'll continue to solve this. And I ended up with 24.6 as my b value. Let me verify that with my calculator. I'm going to perform an n solve, menu, algebra, numerical solve. And I'm going to say 24 equals negative 0.6 multiplied by 1 plus b, comma b. You always have to put the comma. I'm going to hit enter, and it gave me the exact value that I had. So now I can go ahead and I can proceed with plugging in my slope and my b value. So y equals negative 0.6x plus 24.6. Now, they are asking us for standard form. Okay? Standard form means ax plus by equals c. So, I need to rearrange this to have my x and y on the same side, and that a value needs to be positive and a whole number. Okay? So, I'm going to go ahead and move that 0.6x over. Now, in order to get this into a whole number is going to be a super difficult process. Most of the time, what people are taught is they got to find a common factor, multiply it, etc., etc., etc. Mr. Carmona likes to take the easy route to do things. So instead, I'm going to look at this and I say, all right, there's one item behind each decimal, 1 in the tenths place. Meaning, I can go ahead and I can multiply everything I see by 10 in order to get all whole numbers. Notice how now everybody's a whole number. So next thing I want to do is I want to verify that there is no greatest common factor. So I see 6, 10, 246. Those are all evenly divisible by 2. So I will go ahead and I will divide everything I see by 2. I don't see anything else. So this is going to be my answer. Now, how in the world can I verify that? Let me pick a better color here. This guy and this guy are exactly the same because they should be if I did my math correct. So we could graph them, which would require me to go ahead and change this into y equals mx plus b. I don't want to do that because that kind of defeats the purpose of what we just did. But we did talk about systems of equations, and one of them was called infinite solutions, meaning they were the same exact equation. So if I found out what the answer to this system of equations between these two was, it would also be infinite solutions because they'd be the same. In my calculator, whenever I type in two equations that are the same in LinSolve, which is what we use in order to find solutions to systems, it'll spit back something with a C for correct, that they're the same. So let's try it. I'm here on my calculator screen, my actual calculator screen, not the home screen. I'm going to hit Menu, Algebra, Solve System of Linear Equations. It's going to ask me how many equations and the variables. I'm not going to change that at all. I'm going to type in my first equation. Now I'm going to type in my second equation. I'm going to hit enter and notice how it gave me a letter C. If I see a letter C anywhere, infinite solutions, these are exactly the same. So right now we're not dealing with systems, but this is a great tool to verify that you changed your equations correctly. So this is most certainly standard form of the equation that I found. All right, let's take a look at another one. In an electrical circuit, the voltage across a resistor is directly proportional to the current running through the resistor. If a current of 12 amps, and that seems like it might be important, produces 480 volts, how many volts would a current of 1.5 amps produce across an identical resistor? So, this sounds like a directly proportional, direct variation. So what I'm going to do is I'm going to highlight which guys go together. Amps and amps should both either be at the top or at the bottom. And whatever is going to be volts should be at the top together or at the bottom together. So let me read that out again. 480 volts is produced by 12 amps. How many volts are produced by 1.5 amps? And now, of course, we can cross multiply. And I see that I have a coefficient of 12, so I'll divide by 12. And I find out that x is equal to whatever that is. So I'll go ahead and type that in. 480 multiplied by 1.5. 480 multiplied by 1.5, all divided by 12. 60. So my x value should be equal to 60. Now, there is another way to solve this. I can use nsolve to verify my answer. Now, I do want you to notice volts are both at the top. Amps are both at the bottom. They always have to be side by side with whatever the unit or the thing is. Okay? So, let us go ahead and use nsolve in order to solve this. So, I'm going to say nsolve of 480 divided by 12 is equal to x divided by 1.5. And I'm looking for x. And look at that. It spits back the exact same answer. So I got this correct. All right, let's look at the next one. Baseball fans can buy tickets for seats in the lower deck or upper deck of the stadium. Tickets for the lower deck are $42 each. Ticket prices for the upper deck are 75% of the cost of lower deck. Write an inequality which represents all possible combinations of X, the number of tickets for the lower deck, and Y, the number of tickets for the upper deck, that someone can buy for no more than 800. So when I hear no more than 800, I ask myself, can I have 800? Yes. Can I have 801? No. Can I have 799? Yes. So that means that it should look like this. And now I need to go ahead and write out the remainder. Lower deck is X, so 42X. Upper deck is 75% of the cost. 0.75 times 42 times Y. But I don't like how that looks. I want to reduce it. 42X. And I'll find out what 75% of 42 is. 31.5. There's my equation. All right, let's take a look at the next one. Okay. So, a college student needs 11 classes that are worth a total of 40 credits. Now, in order to complete her degree, the college offers both 4 credit classes and 3 credit classes. We're going to write a system of equations that can be used to solve this. So my 4 credits are F and my 3 credits are H. Most of the time, 99% of the time, you are going to see my equations looking like this. It's going to be X plus Y equals the total number of things, and then number X plus number Y equals the total number of whatever else. Money, classes, credits, etc. Okay? So, first thing, I'm taking 11 classes. F plus H equals 11. And my 4 credit classes and my 3 credit classes need to add up to 40 credits. Now I have 2 equations that I can solve. I'm going to go ahead and solve these using LinSolve. So again, menu, algebra, solve system of linear equations. If I really wanted to, I could go ahead and type in my variables f and h, and it'll allow me to do that. I could have also have changed them to x and y. So f plus h equals 11. 4f plus 3h equals 40. 7 comma 4. So f equals 7, h equals 4. Now, I want to make sure that I can also solve this by hand. Okay? So, what I'm going to do is I'm going to try and do an elimination. So I see that this guy is positive 4f. So I need to figure out how to get these guys to cancel out. How can I multiply the top equation to get something that would cancel out that 4f if I decided I wanted to do that? Well, the opposite would just be multiplied by negative 4. So I'd end up with negative 4f minus 4h equals negative 44. They'd cancel here, and I end up with negative h equals negative 4. I'm going to divide both by negative 1, and I end up with h equals 4. Exactly what I got whenever I used the calculator. I can then take this and plug it back in. So f plus 4 equals 11 minus 4, and I find out that f equals 7. All right, let's keep going. All right, so again, this is going to be a system of equations. Anytime x plus y equals total number of things, And whenever money is involved, money times item 1 plus money times item 2 equals total money. Okay? So, a bag contains 18 coins consisting of quarters and dimes. Quarters and dimes, and there's a total of 18. The total value of the coins is $2.85. So, quarters are 25 cents, dimes are 10 cents. Now let's go ahead and try and multiply this and get an elimination. We could also do a substitution if we wanted to, but I like elimination because it's a little bit easier. So I look at this and I say, well, this 0.25 is really a fourth of that. So if I multiply it by 4, it'll become just a regular cube. I can also multiply it by -4 to make it an opposite, so they'll cancel. So let's do this. Multiply by -4. So negative q minus 0.40d equals, and I'll go ahead and use my calculator for that part, 2.85 multiplied by -4, -11.4. All right. So now I can take a look at these two equations and I can add them together. So q minus q, they cancel. D minus 0.4d, 0.6d, and 18 minus 11.4, 6.6. All right, so now I can solve for d. Let's divide everybody we see by the coefficient of d. And I end up with a value of, let's go ahead and type it in, 11 for dimes. So now if I take my 11 and I plug it back in up here, I'll end up with q plus 11 equals 18. Let's move that 11 over. Q equals 7. So I should have 7 quarters, 11 dimes. But let's go ahead and verify that utilizing a LinSolve. Menu, algebra, solve system of linear equations. Remembering that this is absolutely got to be done in the calculator screen. So I changed my variables to q and d. Q plus d equals 18. 0.25q plus 0.10d equals 2.85. 7, 11. 7 quarters, 11 dimes. Exactly what I got earlier. All right. So here again, they're asking us about slope. So I'm going to write down that formula. I always started out by putting in these negatives. All right, let's go ahead and get these values plugged in. So first thing I'm going to do is I'm going to take a look at my numbers. I'm going to try and select my bigger numbers to be my 2s. So I see here this 26 is pretty large, so I'll put that as my x2. And its associated y is my y2. And I'll go ahead and fill in these other guys as well. Noticing that I have 2 negatives makes it a positive. -5 divided by 65. Now, I can go ahead and reduce this. I see they're both multiples of 5, so I will reduce it by 5. And I find out my slope is -1/13. All right, so let me go ahead and do that in the calculator as well. I'm going to run a very quick linear regression. So this is going to be my x's from question number 9, my y's from question number 9. Over here, 26, -39, and their associated y's, 7 and 12. I'm going to go ahead and run my linear regression. I'm going to select my x's and, of course, my y's. I'm going to save the equation to F9, and I'm going to hit OK. Now, it gave me this really crazy decimal here, 0.0769, blah, 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 blah. So I really want to make sure that this decimal is actually what it's supposed to be. So I'm going to head over to my calculator screen. I'm going to type in -1/13 just to verify that it is exactly that number. So I'm going to hit menu number convert to decimal. And look at that. Same exact number, meaning I got that answer exactly correct. All right, let's keep moving on. Okay, here they're asking me to find my rate of change. Rate of change. So, first thing I do whenever I say rate of change, I say, oh, that is just my slope. Slope. All right, so my slope is going to be equal to, whenever we're talking about those graphs, my change in y over my change in x. So first thing I'm going to do is I'm going to select 2 points that go exactly through the corners of the boxes. They already have 2 points laid out for us. So I'm going to go ahead and just use their points. I'm going to use the smallest ones just to make it easy. So first thing I ask myself is, all right, how did I get from way down here to over here? First, I have to go up what looks like 2 boxes, but it's actually 100 units, so we have to be super careful, remembering that sometimes each box might not mean the same thing. Because over here, each box is 50, but over here, each box is 1. So I'll say up 100 and over 1. Over 1 to the right. And it looks like my rate of change is going to be equal to 100. Now, I could have also ran a regression and had it calculated for me. So I would take out this point here, 0, 50, as well as 1, 150. So I'm going to go back over here and I'll start a new spreadsheet. I could go ahead and type over these, but I don't want to mess this up. So I could, if I was crunched on time, go ahead and type in, whoops, did not mean to do that. So I'm going to go ahead and just make sure that I type it into here. This is going to be question number 1. So I'll put these as my X's from number 1, as well as my Y's from number 1. And they were located at 0 and 1. And they were paired with 50 and 150. I'm going to go ahead and run that linear regression just to verify my slope. I'm going to select my X values. And as you notice, my list is growing. So we want to make sure we always appropriately label things so that way you won't be confused. I'm going to let it save as F1. And here's my equation. Noticing that my slope is exactly what I got earlier. So we got that one correct. All right, next one. Again, they want to find the rate of change. So whenever they say that, my first thought is, oh, they're asking me about slope. So I'm going to go ahead and set up my formula here. I'm going to write in my negatives to make sure that I have them. And I'm going to go ahead and take a look at my values and decide which ones I want. I see these guys down here have decimals. I don't want to deal with all that. So I'll use these two at the top. I'm going to look at my X values and I'm going to look to see which one is larger. And it looks like that's 0. So I'll write that in there. The associated Y value is going to go there at the top. My other X, as well as my other Y. So let's go ahead and get those written in. 0 minus 3. Wait, excuse me. 0 minus -2. 3 minus 12. I see a double negative, turns positive, -9/2. So approximately -4.5. I'm going to go ahead and run a regression just to verify this. So I'm going to head back over here And I'll show you how you can do this really quick if you're running out of time. -2 and 0, 12 and 3. Now, of course, that means that these are no longer from question number 1. They are from our current question. All right, so just keep that in mind if you write over them. Now, my slope, -4.5, exactly as I predicted. So let's go ahead and take a look at our next one. All right. So number 10, they're asking me what's my y-intercept. So, of course, the very first thing I need to do is take a look at my y-axis. And I see it's touching at approximately maybe 5.5. I'm not really sure. We can calculate that by looking for our b value in y equals mx plus b. So first thing I'm going to do is I'm going to go ahead and calculate my slope. I could take this and this, plug it into my slope formula, then solve for b. Instead, I'm going to count boxes and say my slope is change in y over change in x. So I'm going to pick out a few points. Here we go. And I'm going to count starting over here, left to right. So in order to get from here to here, I have to go down 3, and over 1, 2, 3, 4, 4 to the right. My slope is -3/4. Now I can take my slope as well as either one of these points, plug it into y equals mx plus b, and solve for my b value. So I'll go ahead and say y equals mx plus b. I need an x value, and I'm choosing these guys because they're the easier numbers to deal with. My y value, as well as my slope. Now, of course, I can verify my b value by running an insolve, and I'll use that to check my answer in just a moment. So let me go ahead and multiply this out. Noticing that's the same fraction again. So 1 equals -4.5 plus b. Let's move that 4.5. And my b value is located at 5.5. I'm going to go ahead and just run my insolve just to make sure that I got that correct. So I'll plug in that original equation. Insolve of 1 equals -3/4 multiplied by 6 plus b, and we're looking for b. And it gave me the same exact answer, 5.5. So we were 100% correct. Now, alternatively, I could have ran a linear regression in order to find this because they gave me this point and this point. So let's do that as well, just to verify. So I'm going to go ahead and run my spreadsheet. These are going to be my x's from problem number 10, y's from problem number 10. And over here I have -2, +6, +7, +1. Let's go ahead and run that linear regression. I'm going to select my x's from problem number 10, my y's from problem number 10, and I'm going to call this F10. I'm going to hit OK, noticing my slope is exactly the same, just like we calculated earlier, and that y-intercept is exactly the same that we calculated earlier as well. So we got this problem correct. All right, let's go ahead and take a look at the next one. Write the x-intercept of each line. So how do we do this? Well, what we need to do is figure out where in the world does it touch each one of these. So let's zoom in. This is not something you could do on the calculator. I see that it's touching at x equals -5. If they asked as an ordered pair, it would look like that. Next one. I see it's touching at x equals 1. If they asked as an ordered pair, it would look like that. Next one. Here, approximately 2.5 maybe. And if they asked as an ordered pair, it would look like that. Over here, same exact thing. I see it touching at x equals 5, which would be located at 5, 0. Okay, so that's how you find the x-intercept. We can look at that and tell right away. Okay, so here they gave me an equation of a line. They said 0.5x minus 2y is greater than or equal to 3. And they're asking me to list 4 solutions and 4 non-solutions. So first thing I'm going to do is I'm going to go ahead and take a look at this equation. I am going to rearrange this to verify how I should shade this and what kind of line it should be. First thing I need to know is I need it to look something like y equals mx plus b. So I need to go ahead and move this x over. Exciting move. As with all inequalities, I have to ask myself every single step, did I multiply or divide by a negative number on both sides? I did not, therefore my symbol stays exactly the same. Now I'm going to go ahead and divide everything I see by the coefficient attached to my variable y. Great divide. I asked myself, did you multiply or divide on both sides by a negative number? I did. Therefore, my symbol is going to change direction. This graph should be read as y is less than or equal to 1/4 x minus 3 over 2. Now, that tells me that this line should be solid and that I should shade below. So I'm going to take a look at this. I'm going to go ahead and draw in my solid line. And let's make it a little bit chunkier there. There we go. All right, there's my solid line, and I'm shading below. I'm going to go ahead and change this color just a little bit. All right, there we go. All right, so now they're asking me for solutions, non-solutions. Anything up here is not a solution. Anything that is located on my line, solutions. Why? Because this line is solid. So all of these guys are going to be solutions down here. Anything in my shaded region, all solution. So I could give you a couple of points. So let's write them. So right here, solutions. I'm going to list out 4 of them. We're just going to pick them at random. 0, negative 3. 4.5, negative 2. Negative 4.5, negative 4.5, as well as 2, negative 2. Those are all solutions. However, anything out here would be not a solution. So stuff like 0, 0, 1, 5, 2, 9, and negative 5, positive 5. All of those are not solutions. Now, the other way that we could do this is we can also test this to make sure that it does that it does validate my equation, meaning I can plug in specific numbers for x and y to verify that it keeps the equation true. So for example, if it is a solution, as 0, negative 3 is, I should be able to plug that in and it should tell me true. So let's head over to the calculator. I'm going to go to my calculator page, and I'm going to say 0.5 multiplied by my x minus 2 multiplied by my y should be greater than or equal to. So I'm going to hit Control equal greater than or equal to positive 3. It says true. That is definitely a solution. So let me try one more. 0, 0. So 0.5 times 0 minus 2 times 0 should be greater than or equal to positive 3. That's false. That is not a solution. Okay, so that's another way to verify whether or not something is a solution in case you get a little bit mixed up doing this part down here. All right, let's continue forth. So here they're asking me linear function f of x is equal to x, and then they're graphing another one that is 2/3 for the slope and a y-intercept of 4. And they want to know which one is steeper and what happened to the y-intercept. Well, first thing, let's go ahead and write this out. F of x equals x. G of x is equal to 2/3 x plus 4. Now, if I remember this correctly, the closer I get to 0, the less steep I am. So this over here has a slope of 1, and I took it down to 2/3, which is closer to 0. It's going to be less steep. And my y-intercept currently is 0 in my parent function, and it went up to 4. So it translated up 4. Okay? But let's verify this by looking at the graphs. So I'm going to go ahead, I'm going to head over to a brand new graphing page. I'm going to call this F16 for question 16 is equal to x. And I'm going to hit tab to add another graph. And I'm going to call this G16. And this is going to be 2/3 x plus 4. And let's take a look at them. So it's a little hard to tell, but let's look at that y-intercept first. Here's my original y-intercept. And I went 1, 2, 3, 4 up in order to get there. So I was translated up 4 units. Now, the steepness is a little bit harder. I can't really tell. So I'm just going to grab my graph and I'm going to keep moving. Notice how eventually this blue guy goes under the red one. So if I was a person walking up this blue one, it'd be a lot easier than going up the red one. So my blue graph is less steep. My original is more steep. All right, so the next problem. So here, originally I was going to have you guys write the equation for each of these, but that's going to take forever, so we're not going to do that. Instead, we're given 2 equations, one of them in standard form, one of them in an unidentified form, and we're asked to take these equations and figure out which one of these 4 graphs those 2 equations are on. So, there are a couple different ways that we can do this, but we're going to do this the easiest way possible. Of course, as you guys remember, we do not know how to graph anything besides y equals mx plus b. So the first thing that I'm going to do is I'm going to rewrite the first equation. I want it to look like y equals mx plus b. So I want to get this guy by himself. I'm going to go ahead and move my 2x over in order to get it by itself. And look at that. We are at y equals mx plus b. So, according to this, it should have a y-intercept of negative 4, which would eliminate this guy. And it should have a slope of negative 2. So I should see at least one graph with a negative slope of negative 2. So I'll look at this guy first. So I'm going to go up 2 over 1, up 2 over 1. So that line checks out. So I'll look at the next one. Up 2 over 1 does not check out. And this guy's positive, so I definitely can't be it. So I'll look at this one. Up 2 over 1. So that one checks out. All right, let's look at that second equation. All right. So here, the only thing that we need to do is get rid of that coefficient. So I'll divide everything I see by -3. And again, we should have a y-intercept of -4, which makes this easy because this is the only graph that has both of them with a y-intercept of -4. This one has a positive slope. Can't use that. Both of them are negative. All right, let's look at the next one. So here we have an equation that we want to solve. So what we're going to do first is we're going to analyze this. We're going to look at it and we're going to say, oh, well, there's one thing after each decimal point. So because of that, what I'm going to do is I'm going to say, all right, there's only one item. So I'm going to multiply both of them by 10. Remembering that by multiplying this coefficient, I'm also multiplying everything on the inside, but I don't have to do that. I have to do one or the other, okay? Just like a greatest common factor. So this becomes a 3. This becomes a 4. And now I can go ahead and start solving this. So I can distribute. I'm going to go ahead and get these x's together. I'm going to go ahead and get my x isolated. So I'm going to do an exciting move. Great divide. And I end up with the value of x equals 2. Pretty simple. However, I want to verify this in my calculator, okay? So I'm going to go ahead and swing over to my calculator here. I'm going to add a new calculator page, and I'm going to use an InSolve menu 3, 1. And inside of this, I'm going to type my original equation. After which I'm going to put a comma X to let the calculator know what it's looking for. And look at that. It gave me the same exact answer that I just found on my own. So we got that problem correct. All right, let's take a look at the next one. Again, another equation they want us to solve. So for this particular one, I see that I have a negative in front of a parentheses. I can distribute that. That is actually a number. They're just trying to confuse us. That's really a -1. But we don't have to write in the 1. So let's start distributing. Same exact process. Remember, if something looks weird or stands out, it's probably something you already know. So don't let it confuse you. So -5x plus 7 plus 4x equals -6x plus 8. All right, let's start combining like terms. Let's get all these x's together because they're all over the place. All right. Let's go ahead and do an exciting move and get rid of the thing that is not touching my x. And a great divide to get rid of its coefficient. And I find out that x is equal to 1 over 5, which is approximately 0.20. So let me go ahead and drop that into my calculator as well, because I want to make sure that I have that correct. Remembering that I can also just type in the word InSolve and put a parentheses. Let me go ahead and put in my original equation, -5x minus parentheses -7 minus 4x close parentheses equals -2 open parentheses 3x minus 4 close parentheses. And we're looking for my x. And look at that, point 0.2, exactly what we predicted based on working out by hand. So this is 100% correct. All right, let's go ahead and move over to the next problem. All right, this is an inequality. So for this particular problem, we always have to be cognizant of the fact that the symbol can change direction if we multiply it and or divide by a negative number on both sides. We have to do that. Not that it's in the problem where we're distributing it. We have to do that, okay? So we cannot check this in the calculator because the state of Texas says that we have to turn off these inequalities in our fancy calculators. However, we can still use an InSolve to verify that we got the number correct, which may be enough to help us pick the correct answer. So first thing I'm going to do is I'm going to go ahead and get started by distributing. At each and every step, I'm going to ask myself, did I multiply or divide by a negative number on both sides? I did not. My symbol stays the same. Now I'm going to go ahead and start trying to get my x's together. Because this is an inequality, I always move in that direction. Always, 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 okay? So what I'm going to go ahead and do, change that color there. All right. So what I'm going to go ahead and do is I'm going to move my 2x over. And then I'm going to ask myself, did you multiply or divide by a negative number on both sides? I did not. Therefore, my symbol stays the same. Now I'm going to ask myself, okay, what do I need to get by itself? Well, I need to get that x by itself. So let us go ahead and do an exciting move, get rid of whatever is not touching my x. I ask myself, did I multiply or divide by a negative number on both sides? No, I did not, so my symbol stays the same. Finally, I'm going to go ahead and divide by the coefficient of x. And I end up here, and I ask myself, did I multiply or divide by a negative number? I did. My symbol changes directions. My answer is all real numbers greater than 3. Now, as I said earlier, of course we can use InSolve to verify this number, this 3, but we cannot use it to verify the direction of this, okay? So, I'm going to go ahead and just type in that original equation to make sure that we got that part correct. Instead, I'm going to change it to an equal sign. And it spits back a 3. So we did do that math correctly. We just have to make sure that we're super careful with those inequality symbols. Alrighty. Let's go ahead and take a look at this guy. So here we have a system of equations. So this is going to be another LinSolve. So I'm going to go ahead and take a look at these, and I'm going to say, all right, I could do substitution, meaning I do an exciting move, great divide, and plug it in, but that might start creating all kind of fractions. So nobody really likes substitution. We like elimination because it's usually a little easier. So I'll look at these and I'll say, okay, 30, 15, negative 12, positive 9. These don't really have anything in common. I mean, they have a 3, but we would have to multiply all the way up to 36. So multiply this guy times 3, this guy times 4 in order to get them to cancel. That's a lot going on. I like to just multiply one equation. So I look at these and I say, okay, 15 and 30. Well, 15 times 2 is 30. So if I multiply it by negative 2, it'll be negative 30 and I can cancel. So I'll go ahead and do that. Negative 2. So negative 30x plus 24y equals negative 26. Now I can go ahead and add my new equation with the second original equation. Cancel. 33y equals negative 22. All right, pretty simple. Now I can go ahead and divide by 33. And I end up with y equals negative 2/3. So I have half of my answer. Now I can take that and I can plug it back into any of the 3 equations. However, I would suggest plugging it into the easiest original equation because sometimes we make a little bit of a math error here. Okay? So, I'm going to plug it into one of these guys. And it looks like probably this guy is going to be the easiest to plug it into. So we'll do that. 30x plus 9y equals 4. And we're going to plug in our y equals negative 2/3. And now I can go ahead and get to solving. I could use an nsolve. I could have used an nsolve with a y. But because this is a system, I can use a linsolve to make sure that I get this correct. So 30x plus negative 6 equals 4. 30x equals 10. And x is going to be equal to 1/3. Now, lots of math, right? So sometimes we can make an error here. That's okay. Let's go ahead and check this with the linsolve. So menu, algebra, solve system of linear equations. I'm going to hit OK, and I'm going to type in those two original equations. And look at that. Same exact values that we predicted based on how we did it by hand. All right, let's look at another one. Here it says a manager purchased a total of 21 coffee mugs and keychains. Each coffee mug costs $8.50. Each keychain costs $2.75. If the manager spent a total of $132.50, how many of each did he buy? So, that's a lot of information there. So what I want to do is first I want to start pulling apart this to get my equations. So I have coffee mugs, keychains, and I bought a total of 21. X plus y equals 21. Coffee mugs are $8.50. Keychains are $2.75. And I spent a total of $132.50. Noticing again that this is following that stereotypical pattern. X plus y equals total. Money times X plus money times Y equals total money. Okay? So, this one is like super complex, so we definitely don't want to have to deal with trying to solve this one by hand. We totally could. We could multiply everything up here by negative 8.5 or negative 2.75 and then start solving. We could totally do that. But for this one, I'm going to go ahead and use my calculator. All right, so I'm going to go ahead and start another linsolve. And this time I'm going to be a little bit difficult, and I'm going to use my variables c and k. All right, so let's type in the first one. C plus k equals 21. And 8.50c plus 2.75k is equal to 132.50. Whoops, there we go. And look at that, 13 mugs along with 8 keychains. So 13 mugs, 8 keychains. Depending on which one they ask us for, or if they ask us for both, our answer might be looking a little bit differently than what we thought. So, next one. Let's simplify this. So, here all we're doing is combining like terms. We're trying to distribute to all that fancy stuff. Whenever we get our answer, we can verify that it is the correct answer by graphing it against the original problem. So let's go ahead and get started. 2x squared plus 1. And anywhere I don't see anything, there's automatically a 1, a 0, or 2. 2 would only be if we're dealing with square root. Everything else is 0, 1. Notice how this negative distributed into here, and this positive didn't do anything. Positive 1 times anything stays the same. Negative 1 times anything changes its sign. Let's start combining like terms. And it should simplify to that. but I want to make sure that I did this math 100% correct. Let's go ahead and graph both of these. So I'll call this Q. The question for number 18 is equal to 2x to the power of 2 plus 4x minus 6x to the power of 2 plus 9 minus 1, minus 6x plus 3. Okay, there is my original graph from the question. Let's go ahead and hit tab and add in my answer for number 18. And this is going to be negative 4x to the power of 2 minus 2x plus 6. And look at that, it lays exactly on there. So that means that we have exactly the right answer. Let's take a look at the next one. All right, so here they gave us this rectangle with these two sides, and they're asking me what is the area. Area of a rectangle is length times width, meaning I've got to multiply these two sides. So yes, I could distribute and do all that fancy stuff, but we like to use our box because it's a little bit simpler. So 5 times 4, 20, x times x, x squared. 5 times negative 4, negative 20. Bring my x down. 4 times 4, 16. Bring my x over. 4 times negative 4, negative 16. And let's go ahead and combine any like terms. And that is my area. 20x squared minus 4x minus 16. But I want to verify that. So let's head on over to our calculator once again. I'm going to start a new graph page, and I'm going to say this is problem number 19. So I'm going to say the question from number 19 was asking me, hold on now. All right, there we go. Question from number 19 was asking me to multiply the two sides of this rectangle. So that's what they look like when I graph them. I'm going to go ahead and hit tab, and I'm going to say, all right, my answer for number 19 looked like this. And I need you to tell me, is it exactly the same? And yes, they are right on top of each other. Notice how they're so close. They actually put the labels right on top of each other. So yes, these are exactly the same. So we got this one 100% correct. All right, let's look at number 6. So for this one, they're asking us to reduce or simplify this. So first thing I want to do is I want to deal with them by type, okay? So we do number, A's, B's, and of course my C's. So first thing I'm going to do is I'm going to draw out that little fraction. I'm going to say 14 over 8 is 7 over 4. A to the power of 4 over A to the power of negative 2. I could move the negative 2 to the top and then add them, or I can subtract them. I'll subtract them today. B to the power of 6 minus 3. And then C to the power of negative 10 over C to the power of negative 5. So I'll subtract those because I want you guys to see the rules can be done in any order. So I see some double negatives. I'll make them positive. I'll go ahead and continue to simplify. 7 over 4, A to the power 6, B to the power 3, C to the power negative 5. I don't like that negative being at the top, so I'm going to go ahead and move it to the bottom. And I am officially done. Now, how do I verify this? Well, there's really kind of a backwards way to verify this. What we do is we just select random numbers for A, B, and C, and then plug them in to see if it matches from here to here. We run a test, is what it's called in the calculator. I always like to choose my variables in alphabetical order. Start at 2, just keep going. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Just to make it simple. So I'm going to go ahead and I'm going to head to a regular calculator page. And I'm going to first go ahead and start a fraction. Control equal. So 14 times 2 to the power of 4 times 3 to the power of 6 times 4 to the power of negative 10, all divided by 8 times 2 to the power of negative 2 times 3 to the power of 3 times 4 to the power of negative 5. And I want to know, because I simplified it, it should be the same, noticing the pattern. There's a lot of things in math that if we do it correctly, they're exactly the same. We're just making it look easier to read. I want to know if it's the same as my answer. So I'm going to start a new fraction. 7 multiplied by 2 to the power of 6 multiplied by 3 to the power of 3, all divided by 4 times 4 to the power of 5. And it says true. Now, use your imagination here a little bit. A, B, C. A, B, C. A, B, C. It's exactly the same. We're just plugging in numbers to verify that the value would be exactly the same. All right, let's go ahead and take a look at the next one. All right, so for this one, they're asking me to calculate the area. So what I'm going to do first is I'm going to highlight that radius, and I'm going to plug it in. So my area equals pi times r squared. Okay. So I'm going to go ahead and distribute this guy. Remember, exponent to exponent. And that should be my final answer. Now, something is weird about trying to test with a pi in there. So I'm only going to test this part and this part. Okay. So let's go ahead and take a look at our calculator. I'm going to say 6 times 2 to the power of 9. And that should all be in a parentheses. Multiplied times 3 to the power of 5. All to the power of 2 should be equal to 36 times 2 to the power of 18 multiplied by 3 to the power of 10. Let's verify. And it is true. So we did that correctly. That is our right answer. But remember, still got to include that pi. So all of this here is my answer. Let's take a look at the next one. Function or not a function? Simple. Do I see any repeating x's? I don't care about those y's. Only the x's. So I'm looking. Yep. Not a function. Not a function. Certainly not a function. And this is a function. So notice, repeating -5, repeating -3, repeating +1, all repeating +2, no repeats. Function, not. Simple and quick. You got this. All right, next one. So here they're asking me to find f of some value. This means x equals whatever's number is inside of there. Meaning, for each one of these, I should go ahead and plug in my x value. And then go ahead and simplify. Now, there's a couple of different ways that I can do this in the calculator, but I'm going to show you the easiest one. Notice how all of these numbers are kind of spaced apart. So just keep that in mind. So I'm going to go ahead and head over here. I'm going to go to my graph, and this was problem number 30. And this is 6 parentheses 1 minus x. Okay, I graphed it. I can look at the table, Control T, and I can look for those x values, right? So -8, -15, etc., etc. But let's say they were asking you to plug in a crazy number, like -4,000, right? We don't want to have to wait that long, go through all this scrolling. So now that I've graphed it, I can head on over to my home screen, and I can go ahead and call it up. So I'm going to say Q30 of -8, Q30 of 20, Q30 of -15, Q30 of 0. So I can actually get all the information that I need by doing this, because we already know how to do it by hand. So I got it filled in, and I'm done. I do want to answer this question. This f of 0. This is going to give me my y-intercept, where it touches the y-axis, my b value, in y equals mx plus b. All right. Let's take a look at the very last question in our review. So this one, they're asking me to change to slope-intercept form. 3x minus 4y equals 6. So I need to get this y by itself. So first thing I'm going to do is I'm going to move whatever is not attached over to the other side. Now I'm going to go ahead and divide everything I see by the coefficient of y. And I end up with my problem in slope-intercept form. However, I want to verify. Did I do this math right? Well, if I did, these are exactly the same, which means if I run a LinSolve on them, I should get a C for correct or infinite solutions, telling me those equations are the same. So I'm going to hit Menu, Algebra, Solve System of Linear Equations. I'm going to hit Enter. I'm going to put in the original equation, and I'm going to put in what I changed it to. And look at that, I got a C, meaning this is correct. They are exactly the same. All right, so that is it for our final exam review. Thank you so much for paying attention. Make sure you take your notes and send me a picture of them.